Yes, welcome to the revision section. And the purpose of the revision section is for us to address questions and concerns that come from the students. Also, on the section of revision, we shall be in position to answer the past papers that the students are going to share with us. So, this is the first question that has been shared. The question is telling us to prove that tan A minus B equals to tan A minus tan B over 1 plus tan A tan B. So when we are solving this, uh, the formulas below are very important. One is the formula of sine of A plus or minus B. And the first one of this formula is that if we are taking a positive part first, we shall say sine of A plus B. This is the same as sine of A cos of B plus cos of A sine of B. Then taking the negative side, we shall get the formula that sine of A minus B is the same as sine of A cos of B minus cos of A, then sine of B. That is the formula for sine of A plus or minus B. And then the formulas for cos of A plus or minus B are 1 for cosine of A plus B. This is the same as cos of A cos of B minus, if it is a plus here, the formula on the right hand side has a minus sine of A sine of B. And then for the minus part is that cosine of A minus B is actually the same as cos of A and cos of B plus, if it is a minus here on the right hand side, we shall have a plus sine of A sine of B. And then the one for tan of A plus or minus B, the first one for the positive side is that tan of A plus B is the same as tan of A plus tan of B over 1 minus tan A tan B. And then the one for minus part is that tan of A minus B. This actually gives us tan of A minus tan of B divided by 1 plus tan A tan B. So this one is what they're actually telling us to prove that tan of A minus B equals to tan of A minus tan of B over 1 plus tan A tan B. So they're telling us to prove that tan of A minus B equals to this right hand side. So what we shall do is, from our previous learning, we have understood that, for example, if you have tan of theta, this is the same as sine theta out of cos theta. So if we are to compare it to that, this implies that tan of A minus B would simply imply that the theta is corresponding to A minus B. So if we are to substitute, this will be the same as sine of A minus. So we are going to substitute. Here, theta corresponds to A minus B. So tan of A minus B equals to sine of A minus B out of cos of A minus B. So since we have understood that, now let me clear it, because we are supposed to use this part of scissors. So we have said that So we have said that this is the same as tan A minus B, the same as sine of A minus B out of cos of A minus B. But what is sine of A minus B? Sine of A minus B is here, the same as sine A cos B minus cos B sine A. So let's substitute for that. This is the same as this sine A minus B is the same as sine of A cos of B minus cos of A sine of B. Divide by, we are dividing by cos of A minus B. But what is cos of A minus B? Cos of A minus B is the same as cos of A cos of B. Since it is a minus, then we can say plus sine of A sine of B. That is if we are following this second one here. So what we are doing is we are trying to arrive at this. So what can we do? If you are proving, always try to do a step that takes you closer to where you are going. Like for example, since there is a 1 here down, so this position of 1 corresponds to this position of cos A cos B. So I should begin to think of how can I make this one become a 1. Somebody could also start by thinking tan of A here just by position is corresponding to sine A cos B. So you also begin to think how can you convert sine A cos B so that it is actually tan of A. So for me, I've seen that I can, like if I divide, if I want to make this one a 1, if I want to make this one to become a 1, that means I should divide it by itself. And we know that any number divided by itself gives us 1. So I want to divide not only this single term by itself, but I'm going to say that I'm going to divide the numerator and the denominator by this. Dividing the numerator and denominator by cos of A cos of B is neutral because those can actually cancel out. We have not made a change to our expression. So let me say dividing numerator and denominator by cos of A cos of B. I'm dividing, and mind you, this is the numerator. These two terms are the numerator. That is sine A cos B minus cos A sine B. That is the numerator. And also these two are the denominator. Cos A cos B plus sine A sine B. So if I'm going to divide, now that means therefore we'll have here tan of A minus B. Now it is going to become sine of A cos of B minus cos of A sine of B. I'm dividing. This is the numerator which we said we are dividing by cos A cos B. That is just the numerator. I've divided it by cos A cos B. And then following that we have already over. Denominator is the same as cos A cos of B plus sine of A sine of B. We are going to divide also the numerator by the same factor, cos of A cos of B. This one means that I have also divided the denominator by cos A cos B. And literally, we have made no change to our expression. Why? If we try to divide, because we are dividing the numerator by the denominator, we shall actually see that the cos A cos B on which is under the numerator here will cancel out with cos A cos B under the denominator. So we have not made any change. Now, let us simplify the numerator. On the numerator side here, we have two terms. We have sine A cos B, then we have cos A sine B, and we are subtracting them. So if it is a subtraction or addition, there is a law of division that the denominator, since we are considering the numerator alone, this is the denominator on this side. That is like it is a fraction of its own. So the denominator is distributed. This is the same as sine of A cos of B divided by cos of A cos of B minus minus cos of A sine of B also divided by cos A cos of B, because the denominator can be distributed if the two terms are being added or subtracted. And for this case, we are subtracting, so that is how the numerator will look. Divide this numerator, you can maintain the brackets, it has no problem, as long as you know what you are dealing with. Also, let us distribute this denominator here. That will give us cos of A cos of B divided by cos of A cos of B. Why am I doing that? I'm distributing this denominator to these two terms, to cos A cos B, and I'm also going to divide sine A sine B by that same denominator. So I've done this part, and then plus this denominator is also dividing sine of A sine of B. It is also dividing, so it is over sine, so it is over cos A cos B. Now this is what I was saying. I was saying that we are trying our ways of possible means that we should get closer to what we are saying. And we have already got one here. Cos A cos B divided by cos A cos B. We are dividing it by itself. So they will cancel out, and that will give us 1. So if you are seeing a step that takes you closer to what you are looking for, immediately you take that step. And then if you do not go to your final stage, then look for the next step that will lead you there. So we are going to now simplify. So we are simplifying. Up here, this cos B and this cos B are going to cancel. They are going to divide and we get 1, which is a unit factor. It makes no difference to our equation. So now here we shall have sine of A. Sine of A will be, we have sine A over cos A. That is the remainder on this side. Also here, let's look for common ratios that are cancelling out. Like cos A and cos A, if you divide them, then we get 1. Now that means please you keep your signs the way they are. That means that we shall have sine of B out of cos of B. Divide by, yeah, remember we still have the general denominator. Also here, cos A cos B divide by itself, that is cos A cos B. That one will give us 1. You are dividing a number by itself, you should get 1. Plus, let's see the terms that are going to cancel out here. There are no terms cancelling out. So since there are no terms that are cancelling out, let's just try to readjust. Why? We can just say it is the same as sine of A, that is true, sine of B. This is a multiplication. Sine A sine B means sine A times sine B. It is a multiplication over cos of A times cos of B. So we are almost there. I think we are a few steps closer. Now let us simplify. What is sine A over cos A? That is tan of A. Okay, that is tan of A. That is tan of A. Why? Because we have seen somewhere that tan, or maybe theta, is the same as sine of that theta out of is cosine. So sine A divided by cos A gives us tan A minus, it is the same here, cos sine of B divided by cosine of B gives us tan of B. Now divide by 1, we solve the simplified plus. Now we're just going to try to separate. It is a product, it is a multiplication. So we can divide these two together. Because you remember, if it is a multiplication, the denominator divides any of the terms on the numerator. Any of the terms on the numerator, provided that all the terms on the numerator are being multiplied, or they are products. So sine of A divided by cos of A, it gives us tan of A. That is, this section alone, these two terms that are being divided, that is sine of A divided by cosine of B, are giving us, divided by cosine of A are giving us tan of A. Also, sine of B divided by cosine of B. Sine B divided by cos B gives us tan B, because it is sine divided by cos is tan. Since it is the same angle BB, that means it's going to give us tan of B. And if you come back here to look at our question, that is what the question wanted us to prove. So this is the answer. This is the proof. So you must keep all this in mind, that these are the formulas for sine of A plus minus B, cosine of A plus or minus B, and then tan of A plus or minus B. So therefore, we have proven that tan of A minus B is the same as tan of A minus tan B over over 1 plus tan A tan B, tan of B. That is the answer. Please, if you have questions, send them to our official WhatsApp group.